we were talking about atoms and the number of electrons and protons that they have, and we just started talking about the meaning of the group numbers on the periodic table. So the number associated with the letter above each main group column, so that's 1 through 8. If we look at that periodic table over there, the main groups are the parts that stick up. So hydrogen is group 1, beryllium's group 2, boron is group 3, and then it continues across. So those numbers are important. That gives the number of valence electrons for the elements in that column. And we'll learn a little more what that means by valence electrons later. But what we're going to learn now is that the main group elements tend to form ions that have the same number of valence electrons as the nearest noble gas. So let's look at the periodic table. How many valence electrons does the noble gas in this square have? 8. All of these are 8 except for helium, which is 2. How many valence electrons does a fluorine atom have? 7. It's in group 7. So how could it have 8 valence electrons? By gaining 1 electron. If you gain 1 electron, what does that do to the charge on the ion? It makes it -1, right? It's very confusing, the whole positive-negative thing. We're gaining 1 electron, but that electron has a negative charge. So that gives it a negative charge. Could somebody get that door back there? And chlorine has 7 valence electrons as the atom. By gaining 1 and having a -1 charge, it gets 8. So look at oxygen. Oxygen needs to gain 2 electrons to have the same number of valence electrons as the noble gas. Okay, so all of these guys are going to form -2 ions. What do you think is going to happen here? That's nitrogen. It's going to have a 3- charge. Because in order to have the same number of valence electrons as neon, the noble gas that's closest to it, it needs to gain 3 electrons. Those are the nonmetals. Nonmetals form negative ions because the closest way for them to get to the same number of electrons as a noble gas is by gaining some. If we look over here at the metals in the main group, how many valence electrons, let's skip lithium, let's talk about sodium. How many valence electrons does sodium have? 1. It has 1 valence electron. The valence electrons are on the outside. They're like like if you think about an onion, it's got layers, right? Every time I talk about an onion, I think of Shrek. But anyway, so this has 1 electron in the outer layer of onion skin. If you peel off that outer layer, what's underneath? Another layer, right? So if we peel that 1 off, what's underneath is 8 valence electrons. The book here is just, it's not the best because it's talking about valence electrons, but it doesn't really tell you what they are. Let's think of it like this. How many electrons does sodium have? That'll be the same as its atomic number, right? So it's number 11 in the periodic table. It has 11 electrons. And the noble gas that's closest to it in terms of number of electrons is neon. How many electrons does neon have? 10. I think of electrons as being a little bit like the clothing of an atom. You can change your clothes, right? You can change your hairstyle, you can change what you look like, but you can't change who you are. Who you are is like the protons. The number of protons identify an atom as belonging to a particular element. The electrons, you can gain and lose electrons. You can take your jacket off, you can dye your hair bright green, whatever strikes your fancy. But you can't change who you are. So the atoms can change their electrons, but they can't change the number of protons. But sodium wants to be like neon. How could it be like neon? It could lose an electron. So if it loses an electron, it's losing a negative charge. It's going to end up with a positive charge. it'll have 10 electrons, it will still have 11 protons. So the book is talking about valence electrons, which is exactly what chemists talk about, but not understanding how the valence electrons work is a little confusing, I think, for you guys. But if we look at potassium, how many electrons does potassium have? Look at that periodic table on the wall. 19. And how could it become like argon with 18 electrons? It could lose one electron, right? All of these guys are going to lose that one electron that's in the outer onion layer, peel off that broken layer, and underneath is a nice full layer of 8 electrons. Look at magnesium. How many electrons does magnesium have? It has 12 electrons. From the group number, we see that it has 2 valence electrons. So magnesium can become like neon. I'm looking at the periodic table and pointing on the screen. That doesn't work. This is neon. By doing what? It needs to lose 2 electrons. So that's why all of these guys form ions with +2 charges. So those are the at least quasi-scientific explanation. So here's the just a trick that works explanation. So pretend that you're playing a board game. And you start in this column, and then the question is, here's phosphorus. The question is, what kind of an ion does phosphorus form? Well, I'm starting here, and I have to move the marker on the game board 3 places backwards. 1, 2, 3. Backwards is minus. I went back 3 squares. This is going to be 3 minus. Selenium. How do we predict the charge? Well, you start with the noble gas and you go back. 1, 2. 2 squares. It's a -2 ion. If you look at the numbers on the periodic table, we see neon has 10, and then 11 is on the next row. Really, it would be great if this was a 3-dimensional periodic table and the elements would just go in this spiral around. So think of this a little bit like we think of maps of the Earth, right? We're familiar with looking at flat maps of the Earth, even though we recognize that the Earth is round. And so we typically see like East Asia and Russia over on this side, and then we see the United States and Canada over here. Well, how do you get from Russia to Alaska the fastest way? Do you go this way? No, you go over that little gap because we recognize that it's actually round. So the closest, didn't want to do that. So if we're playing our board game and we need to get to sodium, the fastest way is to go from number 10, this is space 10, to number 11. And that's actually going to the right, around the back, and we move 1 space in the positive direction. Going to the right is positive, and this would be +1. To get to magnesium, we have to go to +2. How do we get to aluminum? It's +3. The group 3A metals form +3 ions. The group 2A metals form +2 ions. The group 1A metals form +1 ions. So for those metals, I'm presenting you with multiple explanations here, and I don't want to confuse you, but I hope that one of them makes sense to you. You only need to understand one of them, and just cling on to that one. So we need to be able to predict the charges of ions of the main group elements. Any questions? Yes?
What would the 4A form?
That's a good question. What about these guys in the middle? Well, let's think about carbon. If it went this way, it would have to gain 4 electrons, right? And if it went the other way, it would have to lose 4 electrons. So these guys are kind of stuck in the middle. They can form ions, but they rarely do, because they're just they're so far from either side, they either have to gain 4 electrons or lose 4 electrons, that it just doesn't seem to be worth the effort for them. So that's a very good question. Any other questions?
In case they do, which way does it go, or does it?
It would depend on the situation. It would really depend on the situation. Because you could get a C4 minus ion and a C4 plus ion, but both of them are very, very rare. Okay, so based on the position in the periodic table, what ions do potassium and selenium form? Well, first we need to know what the symbols for those guys are. But potassium is K, and selenium is Se. So let's do potassium first. Find it in the periodic table. It's way over there on the left in group 1, right? Is it a metal or a nonmetal? It's a metal. Metals lose electrons and form positive ions, cations. So potassium is going to lose 1 or more electrons. So different ways to think about it. We can count around the board, or we can look at the group number. I think looking at the group number for those metals is the best. It's in group 1A, and so that tells us it's going to form a 1 plus ion. And if we write the symbol for that, it would be K plus. We don't write the 1 because chemists have a thing about writing the number 1. We just, we don't write it unless we have to. So any questions about how I figured that one out? That make sense? You look at those main group metals, the group number tells you the charge. That's really the easiest way. Selenium, where's that on the periodic table? It's over on the right side, right? It's to the right of that diagonal line. So is it a metal or a nonmetal? It's a nonmetal. Nonmetal form negative ions. So selenium is going to have what charge on it? -2. It's in group 6A, and so from 8A we would have to count back 2 spots negative. It'll have a 2- charge. So the symbol for it would be Se with a 2- superscript. Okay? Any questions? Chemistry builds on itself. And this business is going to snowball quickly. So you need to ask questions and get it figured out as soon as possible. I know some people have a tendency of sitting in lecture and they listen and they take notes, but it's like, oh, well, I didn't quite understand that, but I'll figure it out later when I get home. That's not a good strategy. The good strategy is to figure it out in class. Because right in that moment of initial confusion, if you ask a question and get it cleared up, then the next stuff makes sense. I mean, that's basically was my strategy in college. It's like I went to class, I paid attention, I made sure I understood what was being said. And then it's easy. If you don't understand what's being explained, it's not easy. Almost impossible. So please ask questions.